Okay, I want to talk about loan repayment problems. So the question can be something like this: a person takes a loan of amount P that compounds after a certain unit of time, maybe monthly. So, and the interest rate is R, and he or she makes the repayment of monthly repayment, say M, because he or she has to repay. So let's say M, the repayment, monthly repayment. So the question may be how much money he or she owes after certain amount of time, say n months. If it is compounded monthly, m months. If yearly, if annually, then how many years. So anyway, in this case, so let's see how much money that person owes after 1 month. So after 1 month, this is the amount borrowed times the loan. Since n is 1, this is how the compound interest goes. So n is 1, so this is 1, so we just don't write anything there. But he or she also pays back m. Monthly repayment is m, so the money that person will owe is less m because m has been repaid. Similarly, after second month, the interest will be on this whole amount that is still owed, so minus m, 1 plus r, and if I write it like that, so it is 1 plus r square minus m, 1 plus r, but that person again repays back m, so the money owes after the repayment is made. So this is the money that is coming from the interest amount, and this is the amount that is repaid. So finally owed after the repayment is made is this much. Okay, so sorry. So after third month, let's see. So now this is the whole money that is still owed. So that person is still owing this much of money. So this one, the interest will be on this whole thing. So it is becoming 1 plus r. There is a pattern we can see, but yeah. So 1 plus r square minus m, 1 plus r. And after the repayment is made, the monthly, so this is the amount owed after third month before the repayment, and after the repayment is less m. So what we can see is there is a pattern. If we write for n, it will be, see, when it is 3, this is 3, and for m it is just 1 less the power. So for n it will be after n amount of time, and after n months it will be like this: 1 plus r, n minus 1 minus m, 1 plus r, n minus 2 going this way, m, 1 plus r, then minus m. So we can see that this part is a, if we look at it, I will just rewrite it again before making the conclusion, but let's just, so I'm seeing that an is p 1 plus r to the power n, and if I take that amount with a negative sign, m is out, so 1 plus r plus 1 plus r square plus going that way, it will be 1 plus r to the power n minus 1, and then the bracket ends here. So what we can see here is this is a geometric series where the a, that is the first term, is 1 and the common ratio is 1 plus r. The common ratio is 1 plus r. So we can add these all up like from the formula, which is a r to the power n minus 1 r minus 1, where r is the common ratio. In this case 1 plus r is the common ratio and a is 1, so it's becoming 1 plus r to the power n minus 1, 1 plus r minus 1, which will result in just r here. So that's the formula. And sometimes there can be question where it's asked that how much time the person needs to repay the whole amount. So in order to do that, what can be done is when the person owes nothing, the amount owed an will become 0. So the left hand side is 0, this one, so it becomes something like this, and then R here. So yeah, just if we know the P, we know R and M, then it can be solved for, the equation can be solved for N, because it's just one unknown left, and that way it can be found how much time does that person take to repay the whole amount. Anyway, I will do an example later on, but this is just the theory. Just a reminder, in the beginning I didn't tell it, so this is the formula of compound interest, which I have discussed before. So this is the compound interest after 1 month, then after 2 months it is 1 plus R. So this part is this is the interest, and because it's compound, this is the formula to find the total amount with the interest in it. So that's how we do it. I have discussed it in another video previously, but yeah, I just didn't talk about it earlier, and in the beginning I said it mistakenly that I by mistake said that this is loan. So basically this is the amount borrowed times the interest that's coming from the compound interest formula. So that's how we calculate the total amount with the interest in case of compound interest. Of course, after 2 months it will be square here, and say for 3 months it's like 1 plus R cube for n months, cube for n months. This is n. I discussed it before, but just a reminder. So this n. Yep. If we look at this expression, there are actually n terms, because this is 1, but then this one's power is 0. Maybe we can say 1 plus R to the power 0, then 1 plus R to the power 1, then 1, then 1 plus R square, then this way it goes finally into the up to n minus 1. So number of terms are actually n here, and that's why the sum was 1, and then 1 plus R, which is the common ratio. This one is n, number of terms are n, and then the bottom is n, like that. That's why the sum was like that. Also, this expression came by writing the original expression the other way around. I have erased that part, but this one had the initial m had like, so it was going like that, the expression. So all of them were 1 plus R to the power n minus 2, like that, 1 plus R. Similarly, it went up to m. So it's just written in the other way around. So first this term, then this, then the second one, which is 1 plus R, and just writing the other way around, it comes like this. I didn't say it before, but just a little addition there.